Hi everyone. This is just a short lesson explaining about the electromagnetic spectrum and how to solve problems on that. So that's part of your lesson today, and I had a query, so I thought I'd make a little video. So if you look at page 5 of your booklets, this shows you the electromagnetic spectrum. So as you know, there are two types of waves. There's what's called mechanical waves. Those are like sound waves, waves on water, waves on a string, waves on slinky. All these need something to travel through. On the other hand, there's another type of wave that's called electromagnetic waves. And these are, light comes under it, all sorts of waves like radio waves, you've got the whole lot, microwaves, ultraviolet, infrared, X-rays and gamma rays. Now the thing is, these electromagnetic waves can also travel through a vacuum. Now what's common about them is that they all travel with the same speed in a vacuum, and their speed in a vacuum is 3 times 10 to the power of 8 meters per second. That's how fast they go. What's different about them is each of them have their own frequency and therefore their own wavelength. So what does this show? This shows you that when the wavelength is really long, the frequency is quite small. And when the wavelength is really short, the frequency is quite high. So the high frequency waves are at this end, got your gamma rays and X-rays, and the low frequency waves are at this end. You've got your radio waves and your microwaves. Okay, and over here this tells you about your wavelength. Okay, so those are all the wavelengths in terms of meters, and depending on the wavelengths, they've all got their different names. Now, can you see the shaded portion here? This represents visible light. So on either side of it, you've got the infrared and the ultraviolet. Visible light is the light that we can see, and that's white light. But actually, white light consists of 7 colors, the colors of the rainbow. So you've got your violet, indigo, blue, green, yellow, orange, red. So each of these colors, they all travel with the same speed, but each of them have a different frequency and a different wavelength. So if you look over here, they tell you in increasing frequency. So you've got the higher frequency is the violet or the blue and the violet end, and the lower frequency is your red. So the wavelength is different. So at the bottom, you've got your wavelengths here. Okay, now this information is quite useful to solve problems on page, whatever page that is, with your 3 sets of questions under electromagnetic spectrum. So the thing to remember when you start solving the problems is that all these waves are it's connected by what's called the wave equation. So the wave equation is the speed of a wave is related to its frequency and wavelength. So if you multiply frequency times wavelength in a vacuum, the answer should always come up to 3.0 times 10 to the power of 8, which is the speed of the wave. There's also a connection between the term frequency and period. So frequency is how many waves go past a point in 1 second, but the period is the time taken for one wave to go past a point. And the connection between those two is F equals 1 over T. Now, your first question in your booklet on page, let me just get the page, yeah. Here we go. On page 19. So these are the questions that you have to do for today's work. So these ones here. Okay, and I'm just going to solve question 1A, and all those other ones under question 1 is the same. So your first question reads, for each of the following electromagnetic wave frequencies, use V equals F lambda, so that wavelength has got the symbol lambda, it's a Greek letter, and state the type of the electromagnetic wave. So in order to state the type of the electromagnetic wave, you actually have to look at your answer and look at this diagram. So we'll come to that in a moment. So for the first question, so your V is always 3.0 times 10 to the power of 8 meters per second. And for the first one, this is your frequency that's given, and we have to find the wavelength. So this is lambda. So we use V equals F lambda, or lambda is V over F, and then you just substitute for V, which is 3 times 10 to the power of 8, and your F is this number, and you end up with this wavelength. So this wavelength is 5.77 times 10 to the power of -5. So to figure out what sort of a wave it is in the electromagnetic spectrum, if you look at this diagram and if you look at the wavelengths at the bottom, there are numbers here. So we've got 5.77 times 10 to the power of -5. So it's somewhere, it's over here. So just look at the power of 10 times 10 to the power of -5. And if you look up, it's about that microwave infrared region. So it's over there. So this is your infrared region times 10 to the power of -5. So the type of electromagnetic wave is infrared. So that's how you decide, by looking at the power of 10 for your answer. Can you see the power of 10 keeps changing as you go down? So that's what gives you that hint. Okay, now question 2 is where you have to calculate the frequency given the wavelength. So, and also determine the color of the wave. So this one, question 2, is all about visible light. So 2A, the wavelength is given here. And then if you look at the second diagram for the visible light, so you look at the wavelength, you look at the numbers at the bottom, and you can figure out what color it is. So the wavelength for question 2 is 6.9 times 10 to the power of -7. So my 6.9 times 10 to the power of -7 is over here. So it's red. So that's how I know it is red. So looking at these numbers at the bottom. Okay, and how do you solve it? Exactly the same equation. So you use V equals F lambda, and V is always 3.0 times 10 to the power of 8. Now F is V over lambda, and so this is your lambda, your wavelength, and then you get the answer. So you look at the wavelength and decide what color it is, and you just get that from page 5 from the diagram. Is that okay? And then your last question has to do with the relationship between frequency and period. So the relationship is frequency is 1 over t, period is given as t, how long it takes a wave to pass a point, or t is equal to 1 over f. So question A is you're given f, you've got to calculate t, so you just go, t is 1 over f, you just go 1 over that number and you get f. Now there are 2 units in which you can express frequency. It is hertz, Hz, or it is per second. So either of them is correct. And the next one is just the reverse. You're given the period and asked to calculate frequency. So frequency is 1 over t, and you just go 1 over t and you get the answer. Okay, so frequency is hertz or per second, but period is given in seconds because it's time. So I hope that makes sense. And just keep the questions coming, and I'll post these little videos to explain your questions, and I'll post it for all of you to see. So bye for now, and I hope your day goes well.